Well, let's try another binary game. This time it's hexadecimal, the last one of these binary games in this class. So here's how it works. We've got, make this wider if it'll let me, there we go. All right, so you're going to count to 15 in base 2. You can go 0, 1, 1, 0 is 2, 1, 1 is 3, 1, 1, 1 is 7 because it's 1 plus 2 plus 4. And you can get up to 15, which is 1 plus 2 plus 4 plus 8. So that gets you up to 15. And now in hexadecimal, instead of putting base 10, you use the same up to 9 as base 10, and then you use A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. And you get used to this. It's very useful, and you'll see it a lot of places. And you even get used to things like A is even, but B is odd, and so on. I'm going to shove this to the left, so it's hopefully, get my face out of the way. All right. So 4 bits make a nibble, the 1s, 2s, 4s, and 8s. And the nibble is also one hexadecimal digit. You go from 0 to 15 or 0 to F. And that's what hexadecimal is. So 8 bits make a byte. And if you want to know what this number is, 1001, 1001, you can do what we did last time, which is take 128 plus 16 plus 8 plus 1, and that gets you 153. But there's a much better, much faster way to do it, which is read the nibbles. This is 9, 8 plus 1, and this is also 9. So in hexadecimal digits, this is a 9-9 in hex. And that means 9 16s plus 9. You read the 4 bits on the left as a nibble and multiply by 16, and then you add the 4 bits on the right, read as a nibble. So converting from binary to hex is very easy. And getting back to decimal from hex is very easy. Hex sits in the middle between binary and decimal and makes it easy to go back and forth. That's the idea. So let's try a few of these. Here's the challenges. All right, and let me see if I can make this fit correctly on the screen. This thing is not letting me grab the edge for some reason. There we go. All right, so what is this number in hexadecimal? You can type an answer in the chat if you like. I'll wait a few seconds and I'll talk about it, because you might be doing it the hard way. The hardest way would be to turn this into base 10 and then try to turn that into hex. But for nibbles, to move binary to hex, you just read the nibbles one by one. It's 3 on the left, that's a 3. It's 8 on the right, it's 38. You just read it right off of there. The left 4 bits are the high order nibble, and the right 4 bits are the low order nibble. This is 3-8 in hexadecimal. Okay? So try this one. What's that? In hex. I may not have anybody participating. Apparently not. But you read the nibbles. This is 1, 1s, 2s, 4s, and 8s. So this is 1. This is 2. Number 1s, number 2s. So this is 12 in hex. I'll do one more as a demonstration. This one is 1 on the left, and on the right this is 9. 8 plus 1. It's 1s, 2s, 4s, and 8s. So this is 19 in hex. All right. Anyway, that's all I wanted to show you today of this stuff.